So before we talk about atoms and isotopes, let's talk about the idea of elements. These guys that we have been seeing since IGCSE and O levels, and to know that the element that is found, the element, let's say carbon, found on the earth will be the same as if it was found anywhere in the universe. And so that's the unique part about each element. It has the same properties on earth as in on any other planet. And so what we have broken down pure substance to, because what is elements? Element is the most purest form of a substance that has some property. You cannot break an element down further into simpler substances. That's really what an element is. It can't be broken down into simpler substances. We know in the world there are about 92 elements. you know Now we can actually create more elements by literally adding more protons, but generally there are approximately 92 elements, the ones that we know naturally exist. The others we have made artificially by nuclear reactions. uh, there are no more naturally occurring items. We have completed the list. We can't make, because anything heavier after the first 92 or so just breaks down anyways. So we know nothing will exist ahead of this. So we have basically 92 elements. And what's an element is basically a substance that will have only one type of atom. It will have only one type of atom, meaning one atom with a particular proton number. So a compound might have multiple atoms of different elements with different proton numbers, but an element will have only one type of atom that has the same number of protons. That's what an element is. Now the beauty is the whole universe is just made up of these atoms combining in different ratios. In different formats, you get water, you get carbon dioxide, you get molecules that end up making cells and other beings also. So it's just these 92 elements that in various different combinations have been able to make hundreds of thousands of compounds, literally. Okay. And so we understand that the same element that exists in your bones is the same element used to make your brick walls. And the same element that you drink is also the same element you breathe in different forms, which are compounds. So, and sometimes some elements in one form can kill you, while the other form is necessary for you to survive. Okay. And what we know of is these elements are made up of one type of atom, because that's what this class is about. And atoms are actually made up of three more simpler substances. You probably have heard about them. You have. I'm just playing with words. You've probably heard of protons, neutrons, and electrons. Without hearing them, you couldn't have graduated to A level chemistry. So we know. So we're going to focus our attention on these guys. All right. Now, if I talk about the origin of elements, I mean, this is just area. There's just a history, and it's not a history of science, or you could say the history of our elements. It won't affect our syllabus. It's just I'm taking a few minutes to explain that all the elements came from the sun. Understand that. Basically, the sun, which is a star, is made up of hydrogen. Okay. And what the idea was that hydrogen combined with itself and more hydrogens to make heavier atoms like helium, lithium, neon, carbon, oxygen. All of these elements were made when hydrogen elements or atoms of hydrogen underwent what we call fusion, combination. They combined through nuclear fusion to make larger elements. So basically, we started off with the hydrogen, and everything came from hydrogen. And so this is basically nuclear fusion that you might have studied in physics in your IGCSE O levels. But the idea is that initially, when stars are formed, they are balls of hydrogen gas, and hydrogens can fuse to form larger atoms. And where do the hydrogen come from? Energy can create, it can create mass. And eventually this leads up to heavier and heavier atoms like lead, uranium, some really highly radioactive ones. So that's the idea. That's where they come from. Okay. So the basic summary was that the elements came from the stars, basically, and these guys broke off to make planets. Like when stars die, they break off, then debris, then you get planets and rocks. So the same elements that came from the stars went into rocks, sea, and other objects, and into ourselves. So the literally the atoms inside a body once were originally from the sun. That's literally what it was. All that's the scientific, you could say, lineage of each atom. All right. So hydrogen was the first ever element that existed. What was hydrogen? It's simply one proton and one electron. Nothing more simpler can exist than hydrogen. So the first element that was in space was hydrogen. Hydrogen fused to make larger and larger and larger elements. Uh, while stars died, they would blow up. I mean, you heard of terms like supernova, death of a star, temperature cooling, gravity. These guys form rocks combined to form planets. You know, all that stuff that's happened in astronomy. And I mean, you can study it further. It's fascinating. But the same atoms that are involved in, in all of these processes eventually led to the rocks and the sea and us. So that's where the atoms, like, you can trace back down. So the same atom that made you might be the same atom of oxygen that somebody else gave off as carbon dioxide 80,000 years ago, or came off as hydrogen atom from the sun like billions of years ago. So it's all combined. That's basically the summary of the origins of the elements that we know. But obviously, we have to end up dealing with elements that exist on the Earth's surface. This is the one that we interact with the most. And the abundance by mass of the most common elements, some of the most common elements on the Earth, in the atmosphere and on the surface, happen to be oxygen, you might have heard of, silicon in the form of sand and many other things, aluminum also, an element, pretty common. You got carbon, you got iron, sodium, and so on and so forth. Okay. Now, in the Earth's crust, we have different elements. We have a lot of metals also. We've got aluminum, we've got iron, and so on and so forth. In the human body, the most the highest proportion mass elements are oxygen, carbon, hydrogen. We call that organic chemistry, but that's what we have. And there's some nitrogen also, and then other elements. So organic chemistry, these are the most common elements by mass. The Earth's crust, silicon, oxygen, alumina, iron. So iron ores, aluminum ores, pretty common. Calcium ores, all that stuff. This is just an idea that it's nice to know the history and the current what do you call status of these elements.